research presentations, and I have Dr. Congress here with us who's moderating the session. He is from Michigan State University. So Dr. Congress, I'm going to kick it off over to you and let you start the session.
Hi everyone, good afternoon. Hope you are enjoying the colloquium. Today we have some very exciting undergraduate student research presentations. So looks like we are starting probably 15 minutes delayed. So we are going to just move each and every presentation in the same way. So each we have 3 undergraduate students, and the first presentation will be from, let's say, since it's 10:45, so it should be from 11 o'clock your time until, let's say, 20 minutes. So we'll have 5 minutes of Q&A for each presentation. So please stick to your time. And with that, I would like to invite the first student, Matthew Manock. If you can please go ahead and start sharing your screen while I introduce you. So Matthew Manock is a junior civil engineering major at Arizona State University, studying structures, materials, numerical methods, and geotechnical engineering. He gained teamwork skills as a retail sales clerk at Medieval Times and conducted summer research under Dr. Camille Kolosh on sustainable soil stabilization and climate resilient asphalt projects with the National Center for Infrastructure Transportation, NCIT. Matthew also serves as a teaching assistant for a dynamics course, and his research interests focus on sustainable materials and resilient transportation infrastructure. So with that, I would like to request Matthew to go ahead and share the screen. Let's see if Matthew's here. Stephanie, can you please help me if Matthew is able to join?
Yes, I'm currently trying to locate him in our list. He should have already been added as a speaker, but I'm not seeing him here.
Okay. If that is the case, then I can move on to Taylor, who is a Spartan. I can ask her to go ahead and start the presentation. I'll go ahead and introduce. Taylor, are you ready?
Ready.
Awesome. So while I introduce you, please feel free to start sharing your screen. So Ms. Taylor Stenzel is an undergraduate student at Michigan State University who is studying civil engineering with a minor in entrepreneurship and innovation. She's currently assisting a research project on digital collaboration using industry foundation classes and BIM technology. She's involved in Women in Engineering, American Society of Civil Engineers, and Society of Women Engineers. She's also a recipient of NCIT Advancing Excellence in Education Scholarship and the META Scholarship Fund. So with that, I'd like to introduce and give a round of applause for Taylor to start the presentation.
Hi, everyone. Just give me one more second to get my presentation uploaded. Okay, can you all?
We do see the lecture slide, presentation slides here. If you want to change it to present, yes, perfect.
Yep,
thank you.
Good to go.
Awesome. Thanks, everyone, for being here. Like I said, I'm Taylor Stenzel. I'm doing research on digital collaboration using IFC industry foundation classes and BIM technology, and I'm doing this research under Dr. Kristen Chetton. The outline of this presentation includes an introduction of the project, the problem description, and the objectives and methodology of this research, the results and discussion, future work to be done, and questions at the end. To introduce this project, MDOT's assets and their information of these assets are being shared both internally and externally during different project phases. So internally can mean within different departments or offices within MDOT, or externally, which could be like sharing information with contractors. And the different project phases can include design, construction, operation, and maintenance. And data is being lost during these stages because we are currently experiencing physical and digital documents, and data is being lost when users have to manually enter information into the digital documents or data is being shared from one database to another, and there's data loss in between that process. So we're going to use various software packages to attack these interoperability challenges, and we're going to recreate the models of each of these assets and identify loss of information with using data workflow diagrams. The objectives of this project include determining MDOT asset types and required data for each of these assets. This project is mainly focusing on pavements, pavement markings, culverts, guardrails, signs, and ancillary structures. Div includes determining the current MDOT data workflow and handover processes for each of these assets. So this is done by conducting interviews with MDOT. We've had these interviews already, and we met with the pavement asset group for about an hour, and we discussed with them how data is being flowed from the beginning stages of design to the design process to the contracting process to the operation and maintenance, and seeing how data is being flowed from each of these steps within the design, and then taking that information and putting it into a workflow diagram. The next objective includes developing digital project handover processes by using the recommended methods, which are included but not limited to IFC, BIM, or a common data environment. Next, the next objective includes developing a use case study to apply these proposed solutions within the developed digital handover processes. And finally, the last objective is to develop a guideline comparing each of the digital handover processes to show the advantages and limitations of each of the proposed solutions. The methodology of this research started with a literature review where we read up on the current research that is being done on IFC, BIM, and common data environments to see what problems are arising, what solutions are being suggested, and where can we continue and move on with in the future. We then did a collection of the current MDOT asset types, data structures, and workflows. And this process involved those interviews that I was talking about. We did initial interviews with each of the asset groups. So we had hour-long meetings with each of the asset types and took that information, put it into a data flow structure, and then followed up with 30-minute meetings with each of the asset groups to fill in the blanks of information that we were still needing. And with the mapping of the data structures and workflows, we're able to identify points within the data workflows where there's a possibility of data loss. And this is the stage that we are currently at the moment. And after that, we're going to recommend digital project handover processes to improve what is currently being done. So take the data loss and see what solutions or what methods could we recommend to MDOT to limit the loss of data. Then we'll complete a case study on one of the asset types using real data from MDOT to demonstrate these recommended processes that we have. And then finally, we will submit a final report with the project deliverables. So these are some of the current results that we have. You can see the data flow map on the slide, and this is for the sign asset at MDOT. We've currently updated this data workflow diagram since creating this presentation, but this is the preliminary one. And you can see it's a little small, but on the horizontal axis at the top are each of the design stages. So there's the planning and programming, design, the contract development, construction, and then the operation and maintenance. So those are all the pre-construction parts of this specific asset. And then on the vertical axis, you can see the databases, the contractor involvement, and then all the offices that are involved in the Michigan DOT. The light blue lines on the diagram represent information that is flowing from either between people or databases and what information is being shared. So the red text on those blue lines represent maybe it's GIS data, or you're sharing a PDF of plans and things like that. So for the sign workflow, the region and the TSC, they decide, okay, we need a sign in this specific location. They'll submit a job. They'll submit a job into the job net, and then the sign design team will design the sign, and they have templates already made at MDOT that the design team can pull from ProjectWise and make edits to it, and then share their finalized designs to sign review. And the sign review they'll review the signs and make comments or give the all clear. And once the signs are all set with design, a letting package is created and is sent into the contracting office, where a contract is developed and the bidding process begins. And once the project has been bidded on, the sign will be installed, and then the sign will be inspected, and then it's all set for the pre-construction stage. And you can see at the bottom are the databases that are involved with signs, which are the cylinders on the map. And those can include JobNet or the MySigns database or the GIS database, for example. And we are still working on sending out the survey to each of the DOTs, but we created a survey to see where each of the DOTs in the United States are at with different external data sharing information. And so when we get those results, those will also be part of our results and will be added into the asset data flow. Some future work that the team is going to be working on is we're currently working on coordinating interviews with contractors, and this will let us identify what problems that the contractors are experiencing with data sharing and working with 3D models and seeing their opinions and their thoughts on moving forward with the more digital data sharing. Then we're going to also identify points of data loss. Since we're almost done with the data flow diagrams, we'll be able to see the points of data loss and then be able to define possible solutions. And then we're going to conduct a case study, and we are estimating to do this case study on signs. And then we're going to develop guidelines for future use. Any questions?
Great presentation, Taylor. I appreciate it. Please feel free to use the question and answer tab to ask any questions. In the meanwhile, I can probably ask you one question to start with. Can you elaborate on how industry foundation classes and BIM technology can streamline collaboration between different stakeholders?
I can a little bit. The PhD student on this team, he's been doing more of the technical information with IFC and BIM, but there's new industry standards that are happening with IFC right now that will allow for the digital collaboration and will help with moving and sharing the data.
I see. Thank you. Are you familiar with any potential obstacles that might arise in their adoption?
We are aware that different softwares do not talk well with each other, and that's something out of our control. So that's something that we're going to have to take into consideration. And then we're also going to have to take into consideration that not everyone is well trained with all these softwares, and that's something we'll have to work around as well.
Excellent. Thanks for those responses, Taylor. Let's see if we have any more questions.
Hello. If I may ask a quick question.
Sure.
Yeah, hi.
Please.
Hi, Taylor. Thank you so much for a great presentation. And thank you for working on this problem. On your slide 6, where you were showing the workflow diagram, I was wondering what was or maybe there were multiple, what was the challenging stage in this workflow that you've encountered, and whether you got any feedback on how to deal with those challenges? Was it binning? Was it, translation? Was it actualizing information? Just curious.
Yes, so when we were doing the interviews, we had a hard time getting information for kind of the more operation and maintenance phases because when MDOT signs off with the sign project, they don't really see the project ever again, and that is where some of the data loss is, because once they hand it off, they never really see or hear from it ever again, and where if a sign had to be reconstructed or anything like that, they don't necessarily know about it, and so their information is not updated into their databases.
Thank you.
Thank you.
So looks like those are all the questions. Again, thank you so much, Taylor, for the wonderful presentation. I'd like to applaud for presenting a very exciting one. So with that, I would like to invite Markus Hartfield from Prairie View. While I introduce you, please feel free to share your screen and set it up. So Markus Hartfield is an undergraduate civil and environmental engineering student at Prairie View A&M University. Before joining Dr. Alam's research group, he was vice president of the NAACP and briefly served as president of the AC student chapter. Since starting his studies in fall 2019, Markus has developed a strong interest in geotechnical engineering, focusing on real-world applications. His research explores innovative sensor technologies to detect subtle changes in Earth infrastructures with the goal of expanding his knowledge and contributing to future projects. With that, the floor is yours, Markus.
Yes, sir. Thank you. Is everybody able to see my screen?
Yes.
Yes. Okay. Well, hello. Thank you for the introduction. Again, my name is Markus Hartfield. I am Dr. Alam's research assistant here at Prairie View A&M University. I will be presenting our sustainable slope performance monitoring using Internet of Things presentation. All right, this is our presentation outline. We will first have our introduction, followed by problem description and objectives, the methodology for this research and discussion, future work, and we'll have Q&A at the end. All right, first I'd like to introduce our team members. Our supervisors are going to be Dr. Alam and Dr. Ahmed. The research assistants include myself, Luis, Raul, Omar, and Sanaya. We're going to talk about landslides and what they are. Landslide, known as a landslip, slope failure, or slump, is an uncontrollable downhill flow of rock, earth, debris, or the combination of the three, which is why the landslide gets worse as it comes down the hill. Some causes of the landslide could be failure of the materials that make up the hill slopes and are intensified by gravity. Another cause could be when the ground becomes too saturated, it loses its stability, which loses its ability to its equilibrium over time. Basically, that's what causes mudslides as well. More causes could include climate, weathering, erosion, or man-made interferences like mining or clear cutting. And clear cutting is just like the process of just cutting, taking away like the internal structure of the ground, so taking the roots from trees, causing like a shift in equilibrium in the soil. These effects of landslides could be loss of life, decimation of the landscape, economic decline, and it can negatively impact the ecosystem. The problem and description and the objectives. As we discussed, landslides and slope failures prove great risk to transportation infrastructure and can cause damage, fatalities, and economic loss. Monitoring slopes is labor intensive, expensive, and is not in real time. So like before a landslide happens, we don't have the proper resources to anticipate it. So we don't take care of it after it's already happened. So timely monitoring of slope performance is crucial. Our objectives of this research project was to develop a low-cost monitoring system, collect data and analysis in real time, develop a protective and early warning mechanism, as well as create a system for field application. Our methodology, we have 6 total sensors, but there are only 3 types of sensors, so we have 2 of each. The tilt sensor, which is the device used to measure the angle or the tilt rotation of the structure, such as the slope or the embankment, and we have 2 of those tilt sensors at the top of the slope. The tensiometer, which is a device used to measure the soil's matrix suction or the water potential, indicating the moisture content and cohesion within the soil. So higher suction would mean that the soil is drier, which affects the slope stability. And we have 2 of those under the slope. Then we have the co-located moisture sensors. It's a moisture sensor installed at specific depths that ensure the soil moisture and matrix suction data is accurately recorded from the same point underneath the slope. Right here we have our soil properties. I'm gonna take a little time to explain what each of these are. So you see we have our liquid limit, plasticity index, specific gravity, fine fraction, soil classification, OMC, and MDD. So liquid limit is basically, it's the water content which the soil changes from plastic to a liquid state. As long as, so we have our range from 65 to 71%. As long as it stays within that range, we're operating within a safe limit. If it goes below, that means the soil is too dry. If it goes above, that means it starts to go into the oversaturated, which that's when you have your landslides and your mudslides. The plasticity index is it's a water content at the change from a plastic to a semi-solid state. And we have that at range from 39 to 48%. Again, as long as we operate within that value, this range of values, then we operate within the safe parameters. Specific gravity is that's just with the type of soil that we have, and that goes to the soil classification, which is CH, which is like a fatty clay soil. Our fine fraction is less than 95%. It just shows fine fraction is literally how many fine aggregates are within the soil content that we had for our sample, and we had a little under 95%. OMC, which is our optimal moisture content, is range from 17.2 to 17.5%. Again, that is the optimal range that you want to stay within to make sure that the soil is workable. Then our MDD, which is the maximum dry density. Maximum dry density is the highest density soil can be achieved under compaction at its OMC. And so this density is achieved through when the particles are packed as tightly as they can, minimizing the air gaps. All right, these are some of the variables that we monitored. Is slope tilting and rotation, also known as pitch and roll. These are terms describing the rotational movement of the slope. Pitch refers to the rotation parallel to the slope, and roll is perpendicular rotation. These metrics help in detecting small slope movements. Volumetric water content is the variation in the soil, VWC. These are 2 graphs for our preliminary results. The top graph is our tensiometer and our co-located sensor. We had those two different types of sensors, is a Teros 21 and Teros 11. The top 2 lines is going to be the metric potential, and the bottom 2 lines are going to be the water content. This graph, this was from one of our earlier samples, and as long as the middle 2 lines, if they're within the water content lines, that means we're operating within safe parameters. The bottom graph shows the tilt angle, the pitch and roll. This one it showed a rotation variation of 0.03, so we didn't have a whole degree of rotation, so which is good, as we don't want too much variation when it comes to the slope. Our future objectives are going to be to integrate advanced machine learning and predictive analytics, optimize for low cost and scalable development, develop comprehensive early warning systems, and as well as enhance user interface for broader usability. Do you have any questions?
Thank you very much for the presentation. Oh, thank you very much for the presentation, Markus. Did anyone unmute themselves to ask a question? Let's see. Looks like I don't see any questions asked yet. Let me start with one question. So, what advantages do you see in using IoT technology for slope performance monitoring, and how can it improve long-term maintenance?
Okay, so the advantages I see is just being able to, and how I describe it, being able to have a solution for a problem before the problem even comes up. So with the tilt sensors, with the sensors, you'll be able to anticipate shifts in the soil, or say after heavy rainfall, you can read the moisture content of the soil. So you know if it gets to a limit to where a landslide or a mudslide can come, or the shift becomes too great, it works outside or exceeds like the safe parameters, you can already jump ahead on the necessary steps to either prevent it or to say wherever it's going to happen, wherever it's around, be like, hey, this is incoming. Like it's in landslides, it may happen with rainfall, so you can have people start safety measures, get people to evacuate a certain area, or you can I would say, like, before you start building, it'll help you design your building, because you'll know what type of soil you'll be working with, so you won't have to worry about how it's going to act when something happens to it.
Yeah, excellent answer. I'm actually teaching soil mechanics, so your presentation was a very good refresher for my students who also. So I see Licia joined. Please feel free to unmute yourself, Licia.
Thank you. And thank you, Markus, for the great presentation. Yes, was likewise a great refresher for me. I was wondering if there's a database that assesses geographically the soil properties that you were talking about, and if you were using any of those databases in your predictions, or potentially if these efforts have been made that you are aware of. Thank you.
Okay. So I know I dealt again most of like the geo work. So a couple of research assistants, the grad students there, like the computer science. But I know that we had a data logger. We had a ZL6 data logger that collected all of our information that we gathered through our research so far in our experiments. And the way that they have it set up, it's set up, it's connected to a website that we are developing, and it'll give you real time, I guess, readings of what's happening. And so we're trying to get it to where you can access it mobilely, so you don't have to be like at a computer or at a desktop to read what's going on. You can have it in hand. So I guess it's easier to monitor. But like any more specifics, as like when it came to like actually like putting the data in, I would have to discuss more with my other research assistants partners.
Sure. Exciting. And this is the website you're working on?
Yes, we're currently working on one right now.
Great news, and thank you for clarification. Thank you.
You're welcome. Thank you.
Thank you, Licia, for the wonderful question. And thanks, Markus. We'll probably see if, okay, I think Dr. Perkins has a question. I'll read it out. What are some things you enjoy about serving as an undergraduate researcher? It's an excellent question. Markus?
Just being able to work with people in different fields. Like I said, working with the grad students and their computer science majors, it's showing me like, hey, we really work. We need so many different fields to, achieve a common goal, and you can't have one expert in one field to do everything. You need multiple people. You need a team. You can't engineer is a complete team effort. And it shows when it comes to doing a project like this. You can't do it all by yourself. And just geotechnical engineering, you need computer science. You need even in the environmental, you need water resources. just all being able to see all that come together to achieve one goal is just, it's fun.
Absolutely. Thanks for sharing your experience, Marcus. I agree with you. Modern day problems need modern day solutions, right? So
Right.
you work with interdisciplinary teams. So that's great. Let's see if we have any other questions. We'll just give maybe a couple more seconds. If not, let's give a round of applause for a great presentation to Marcus, everyone. So thank you so much, Marcus. Appreciate
Thank
it. So Matthew, if you can please unmute yourself and start sharing while I will introduce you again. So Matthew Manock is a junior civil engineering major at Arizona State University studying structures, materials, numerical methods, and geotechnical engineering. He gained teamwork skills as a retail sales clerk at Medieval Times and conducted summer research under Dr. Camille Kalush on sustainable soil stabilization and climate-resilient asphalt projects with the National Center for Infrastructure Transportation, NCIT. Matthew also serves as a teaching assistant for a dynamics course, and his research interests focus on sustainable materials and resilient transportation infrastructure. With that, stage is yours, Matthew. Please feel free to.
Good morning. As you introduced me, my name is Matthew Manock. I'm a junior at ASU studying civil engineering. I'm currently working under Dr. Jolina on the project titled A Sustainable Solution for Making Climate Resilient Asphalt Pavements. It's an honor to speak with you all today. I'm grateful for this opportunity. All right, so I'm going to quickly, this is the rundown for the projects. Just going to give you information about it and what it is, what we do. So in Phoenix, Arizona, we've broken a very unfortunate record of having 113 days in a row over 100 degrees. Our climate conditions are changing, and we need to prepare our infrastructure for a hotter and drier future. Also, high fuel and energy usage contribute to greenhouse gas emissions, making it essential for us to adopt cleaner energy sources and improve fuel efficiency. We need to find more sustainable ways for roadway material manufacturing. So the increased temperatures are creating significant challenges. The first one would be heat. Heat is destructive and can cause buckling and softening of the roadways. So very unfortunate for just driving to work. You might hit a crack, not helpful. All of the heat damage creates increased costly repairs. Repairs also can cause roadway closures and delays and create frustration all around. And lastly, increased temperature roadways shorten the lifespan of the materials. So when the current pavement products were installed, they didn't really account for levels of heat and increased loading from our vehicles being applied. So we need to account for that in the future. In light of those significant issues, we are going to propose the aerogel property that we've been working on in the lab, and I'll dive into that right now. So after the, what our product is recycled aerogel for construction materials, which is RAC as well, a combination of both. And there it is right there. It's kind of what it looks like in essence. Later in the slideshow, we'll show you what the final product looks like for now. But in essence, it's sieved recycled aerogel for the specific sizes. And then it's mixed with the crumb rubber at certain temperatures, ratios, and speeds, because we were trying to find the most optimal way of doing it. So that was the first step of the three main steps that we're working on, which would be the mixture design. The next two steps would be laboratory performance testing, which I have been doing for the past couple months, and then pavement performance testing, which will be in some time. So on the left there, we can see the batching of the aggregates used for the testing. That's just one of many that we've done. On the right side, we have the rack combined with the aggregates. So this is what our sample laid out looks like, mixed with the binder and the rack. And lastly, on the bottom there is one of our GMB testing samples that we've created using the mixture. So those were the more simple tests. I will preface these machines here that I'm going to talk about. I have not used. I am not qualified to use them just yet, but in essence, here are what they are. So first, we have the dynamic modulus test. In essence, it just measures the stiffness of the asphalt mixtures across different temperatures and loadings, just to provide insight into the pavement's expected performance under different traffic conditions and climate conditions. And then the next one would be the C fracture test. Assesses the fracture resistance of the asphalt mixtures by evaluating crack propagation under loading. It pretty much helps protect fatigue life and cracking potential. The third one there, the IDT test, the indirect tensile tension test. It determines tensile strength and temperature susceptibility of asphalt for cracking or assessing cracking resistance at low temperatures. The semi-circular bend test, the fourth one there, would be evaluating the fracture toughness and resistance of asphalt mixtures to cracking, which is again important for determining durability and longevity of the samples. The Hamburg wheel tracking test simulates wheel loading on asphalt to measure rutting resistance and moisture susceptibility. It's critical for performance in high traffic and wet conditions. We won't have many of those, but we do. And lastly, the flow number test quantifies the permanent deformation characteristics of asphalt under repeated loading, which is, again, useful for predicting rutting potential of pavements and longevity and durability. And then I didn't put one on here, but it's also the expansion and contraction as well for the FlowNet test. It helps measure how asphalt and concrete materials change in volume with temperature fluctuations, which is, again, very helpful for, this one is helpful for assessing thermal susceptibility and preventing cracking in various climates. So that's the bigger stuff that I haven't worked on yet, but fun stuff. And lastly, we will go over the methodology for the AASHTO wear pavement. Again, haven't worked with it yet, but it's very exciting. It helps predict pavement performance based on all the different properties, climate, material, traffic, and like it says there, it simulates long-term pavement behavior and helps optimize pavement structures for durability, cost effectiveness, and service life. So using the technology will, in short, reduce the use of raw materials, reuse waste materials, improve production processing costs, and lower energy consumption and waste generation. Big stuff. We need to start doing these things if we're going to make a difference and really make an impact on our roadways and actually make them better. Lastly, for future work, we haven't got there yet, but we will prepare samples for the performance testing. We'll run these tests and determine the effect of adding the rack, different variations, to see what the most optimal use of it is in terms of stiffness, rutting, and cracking. And lastly, we'll assess the pavement performance based on the predictions we've made. And we will run life cycle cost assessment and life cycle analysis. Do you have any questions?
Thank you for an excellent presentation, Matthew. Appreciate it. Please feel free to use the question and answer tab to put forward any of your questions. while they do that, I have one question for you, Matthew.
No.
How do you envision your climate resilient asphalt pavement design being implemented on a larger scale?
On a ladder scale, well, I'll give you the short scale and I'll see where I start there. Recently, over the summer, we placed part of the aerogel in a parking lot in front of a Target up north from here. But to go in the ladder scale, you know, I like to actually put this to use. I live on campus here in Tempe. We have a lot of problems with our roadways here because it's a very compact area. So roadways tend to get cracked pretty easily. But getting that spread out, not just through ASU, but, you know, really high compact areas, getting those roadways, you know, I don't want to run over cracks every day. I like a nice smooth road.
Yeah, thank you. Do you foresee any challenges for this to make it as a standard practice in the industry?
Well, I am pretty young, so I wouldn't know about all the technical sides of things, but if I were to guess, probably obtaining the certain components of what's necessary for the creation of this stuff. Obviously, the recycled rubber isn't too hard to get, at least to my knowledge. The aggregates, I'm not sure if we'd be obtaining them from on-site or not. But in essence, I'm not sure. I would like to think it's a fairly simple process, but I don't.
I see. Thank you. Hopefully we can try it out in ASU as well as Michigan so that we can try out the extreme weather, both sides. So with that, let's give it maybe a minute to see if we can have anyone else joining in. In the meanwhile, please feel free to unshare your screen, Matthew. Maybe. So I think with that, I don't see any. Let's give a big round of applause to Matthew as well. And I would like to request the other. I'd like to request the other two undergraduates and Haley, Stephanie, all of you, if you can be in the same frame, maybe we can have a screenshot and call it a day.
Absolutely. And I just want to mention that Judy did write a comment in the chat. I think this is for Matthew. She's asking, what are some things you enjoy about serving as an undergraduate researcher?
Well, I started over the summer before I started my geotechnical and materials courses. And I love to get my hands dirty. As Surya previously said, I worked at Medieval Times, so that was a very retail experience. And now I get my hands dirty and in the field, and I just love that a lot more than handing people money and taking theirs. And I get to know more about what I'm doing in my classes, which is always great. So
that's great to hear. If I could go ahead and have Taylor and Markus turn on your cameras so we can go ahead and take a group photo.
And Dr. Perkins,
Yes.
Everyone involved in the leadership team, please. I mean, we don't need to invite you to your colloquium, so please.
I was going to ask if I could join the group picture.
$5, please.
Okay.
So if everyone is in there, we will go ahead and screenshot.
Yes.
So please freeze for 2 seconds. Looks like Yachi, I think I didn't catch you. Maybe I'll do one more. If you don't mind, guys, smiling one more time for me. Let's see. Perfect. I think I got multiple, so that's good. And again, you guys, Taylor, Markus, and Matthew, you guys are the dream for a moderator. You guys are on time, which is great. So now Haley will not yell at me for not completing the session by 11 or 12. So thank you guys, appreciate it, and we look forward to hearing more about you. Okay, have a good day.
And just to let you guys know, Dr. Grind and Dr. Yachi, they were judges for this session. So we'll have 2 different judges on tomorrow for the graduate session.
Nice. Thank you.
All right. With that, I think we're just going to go ahead and transition into our second partner highlight video. So from there, this video is going to include Texas A&M University, Texas A&M Transportation Institute, and Prairie View A&M University. So Haley, if I could go ahead and get you to launch that video.